Hi, Ho students. Mr. Kaczynski with you. About to do the solutions for 2.3. Practice your skills. Here we go. We're supposed to find the value of x in each proportion. I'm going to use the methods we learned in this unit. So let's do 3.25 feet over 1 meter. I'm going to lose the meters here. I'm going to flip this over is what I'm doing. X over 15.2. And then I'm going to multiply both sides by 15.2. So that'll give me what x is. X should be just the product of 15.2 and 3.25. 15.2 times 3.25, and we get 49.4. And I attach my measurement to that again. That is feet. Of course, we can check our answer. I probably won't take the time to do all of mine, but I definitely would if I were you on an assessment. 1 divided by 3.25 is that ugly decimal. 15.2 divided by my answer, 49.4, is the same ugly decimal. So I know I'm right. All right, this one, let's multiply by 25 here. Multiply by 25 here. And the product of 25 and 1.6 should give us our solution, 40. 40 what? 40 kilometers. All right, this one I'm going to have to flip over. 1 over 0.926 equals x over 200. Yes, there are other ways to do this, but I'm using the method we learned this chapter. Multiply by 200 here. Multiply by 200 here. And in the calculator, it's 200 times 1 divided by 0.96. I'm not going to put point or times the 1. Just do 200 divided by 0.926. It gives me our solution. X is about 215.98 yards. I guess maybe I could have just said 216 yards, but that went 3 decimals, so I give my answer to 2. That's kind of my rule of thumb. Let's multiply both sides by 350 here so we can get x by itself. Multiplying by 350 on both sides. So all I'm going to do is 350 divided by the 0.6. And we get x is, I don't know, about 583.3. That's our answer, kilometers. Going. Multiply by 12 to get rid of this 12. Do the same thing on both sides. This is that conversion factor that we saw in today's lesson. 12 times 2.54 is 30.48. X is 30.48 centimeters. One more. We're going to have to flip this one over. So let's make it 3281 over 1,000 equals x over 100. Let's multiply both sides by 100. And we'll type this into the calculator. 100 times 3281 divided by 1,000. 328.1 feet. 328.1 feet. All right, moving on. Use this conversion factor that 1 ounce is about 28.4 grams to answer these questions. How many grams does an 8-ounce portion of prime rib weigh? So I'm going to go x grams for every 8 ounces. And then over here, I'm going to go 28.4 grams is about 1 ounce. By putting my unknown on top, it saves me from having to flip it over later. So what am I multiplying both sides by? 8. And that gives me that x is a 28.4 times whatever, times 8, 227.2. Let's put a unit of measure on there, which is grams. 8 ounces is 227.2 grams. Let's try it again. If an ice cream cone weighs 50 grams, how many ounces does it weigh? So let's go x ounces. That's where I always start with my unknown. And let's do 50 grams. Okay. Then, what do we know? We know 21 ounce is 28.4 grams. So I'll multiply both sides by 50 to get rid of this 50 that's under my x. So really it's just 50 divided by 28.4, and that comes out to 1.76-ish. Let's go, x is about 1.8, let's go 1.8. 1.8 ounces. One more. Typical house cat. Let's go orange. Weighs 160 ounces. How many grams is that? X grams is 160 ounces. And we know that 1 ounce is 28.4 grams. So I'm going to say 28.4 grams is 1 ounce. And then I'll multiply both sides by 160. Cancel these out. And it just ends up being 160 times 28.4. So that's 4,544 grams. Use this conversion factor. 1 inch is about 2.54. That looks familiar because that's the one we used today in class. All right. Teacher 62.5 inches tall. How many centimeters tall is she? So I'm going to go x centimeters is 62.5 inches. And then the ratio we figured out is that 2.54 centimeters is 1 inch. Let's multiply both sides by 62.5. And we get that x is 2.54 times 62.5, 158.75 centimeters. Here we go again. Common ceiling height, 96 inches or 8 feet. 8 times 12 is 96. About how high is this in centimeters? So let's go x centimeters and 96 inches. And then we'll go 2.54 centimeters is 1 inch. Multiply both sides by 96. .54 times 96 is 243.84 centimeters. Diameter of a CD compact disc is 12 centimeters. What is it in inches? So now this is different than the other ones because we're doing x inches, 12 centimeters. And then we're going to go 2.54 centimeters on the bottom and 1 inch on the top. Going to multiply both sides by 12, but it's really that I'm dividing by 2.54 now. So it's x equals 12 divided by 2.54. It's about 4.7. Let's call it 4.72. How's that? Inches. Dimensional analysis. Now, you can't know what dimensional analysis is unless you read the rest of section 2.3. There's a pretty good description of it in example B on page 114. 60 miles per hour. That's what's given to us. 60 miles for every 1 hour. This is different than solving a proportion. We're going to convert this into miles per minute. It's a little bit different. Same process. So I know that every 1 hour has 60 minutes. So see how I just canceled out hours right there? So it's really 60 divided by 60. And it comes out to 1 mile per minute. 60 miles per hour is 1 mile per minute. Let's do it again. I'm going to use similar color coding. Let's start with orange. Let's start with blue. 4 miles per hour. 4 miles for every 1 hour. And I want to convert this into feet per second. Well, I got to change miles into feet, and I got to change hours into seconds. Let's start with the hours. So 1 hour is 60 minutes. So if I divided 4 by 60, I'd have miles per minute. But I want to get to seconds. 1 minute has 60 seconds. See how I just canceled that out? So 4 divided by 60 divided by 60, that would give me miles per second. But I don't want miles, I want feet. Okay, so now we're going to do that. I'll change colors, how about that? Times 1 mile. I put it on bottom so I could cancel this out. That's 5,280 feet. Is that anywhere given in the book? I hope. Not really. So hopefully you looked it up. All right, here we go. I think we got everything we need. What are we down to here? The only thing I didn't cancel out were feet and seconds. So let's go 4 times, we'll just go right in order. 4 divided by 60 times 5,280. That is 5.9 feet per second. So someone that's going 4 miles per hour is going 5.9 feet every second. Here we go again. 50 meters per second. 50 meters for every 1 second. What am I trying to turn that into? Kilometers per hour. 60 seconds, cancel, is the same as 1 minute. And 60 minutes is the same as 1 hour. Cancel. So now I'm down to hours. Now I need to change meters to kilometers. 1,000 meters for every 1 kilometer. Notice how I'm writing the unit down every time because it helps me place things. Top, bottom, they cancel out. I think I got everything I need. I'm going to have this in kilometers per hour. That is equal to, so let's go 50 times 60 times 60 divided by 1,000. 180, nice round number. 180 kilometers per hour. 0.025 of a day into seconds. 0.025 of a day. Yeah, I guess kind of messed that up. Let's try this again. 0.025 days. All right. Every day has 24 hours. Just start with what we know. Boom, cancels. Every hour has 60 minutes. Boom, gone. Every minute has 60 seconds. Cancels. And I'm done. 0.025 of a day is just 0.025 times 24 times 60 times 60, 2,160 seconds. One more of these. Ounces to tons. So let's start with what we're converting. 1,200 ounces. 16 ounces in a pound. That's going to help me. 16 ounces in a pound. And then 2,000 pounds in a ton. 2,000 pounds in 1 ton. So for this, since those numbers are on the bottom, I'm actually doing 1,200 divided by 16 divided by 2,000, which is 0.37, oh, missed a zero, 0.0375 tons. It's not very much. That is called dimensional analysis right there. Read example B, hopefully. Hopefully you tried a few of those on your own. In 2001, Alan Webb broke Jim Ryan's 36-year-old high school mile record by running 1 mile in 3 minutes, 53.43 seconds. How fast was this in feet per second? So up here we had somebody, this is like walking 4 miles per hour, 5.9 feet per second. How fast was this guy going when he broke the mile record? All right, let's try it. So let's go 3 minutes times the fact that there's 60 seconds in a minute, and that gives me 180 seconds in 3 minutes. So really what I'm trying to do is convert 180 plus the 53.43, that is 233.43 seconds. That's how long it took him to run this, okay? To run 1 mile. I'm trying to do it in feet per second. You know what? I'm going to turn that upside down. This guy ran 1 mile in 233.43 seconds. Okay, let's change the seconds into, no, all we got to do is change the feet into the miles into feet. Okay. 5,000, it's a multiplication sign, sorry. 5,280 feet are in 1 mile. So 5,280 divided by 233.43. 5,280 divided by 233.43. 22.62 feet per second. Okay, that makes sense. I mean, 4 miles per hour, you're walking about 6 feet in a second. That's not very fast, 4 miles per hour. But if you're breaking the world record, the high school record for a mile, you're going to almost 23 feet per second. So over 3 times as fast. 12 miles, maybe 13 miles per hour, something like that. 14 miles per hour. Whew, it's cooking. Okay, that's all I got for you. Have a good one. Hopefully this helped.